Now we're going to start a very fascinating topic called linear transformations. That's really the bulk of chapter 6. So let's just start. A transformation is just a fancy word for a function. And it's a function that goes from the vector space V to the vector space W. So V and W are both vector spaces. So the transformation takes vectors from V, vector space V, to vector space W. And if you remember, we kind of mentioned this idea back in differential equations when we talked about Laplace transform, that a typical function, you throw in a number and it spits out another number. But in an operator, we said you throw in a function of x and it spits out a different function of x. We said derivatives are an example of operators. But a transform, we said you take one type of function and it gives you a whole different kind of function. If you remember, Laplace transforms took a function of t and then changed it into a function of s. So anyway, so V is a vector space, and we call that as the domain of our transformation t. T is the function or the transformation. T takes the vector V and turns it into and outputs it into the vector W. We're looking at this, sometimes we call this a map, but we look at it as we're going from V into W, but otherwise we write it this way. Anyway, W is called a codomain, and here that's the range. And a range means, well, you know what range means. Vector W is called the image of vector V under the transformation T, and vector V is called the preimage of vector W. So here's an example. T is a linear transformation from... Oh, by the way, so far I haven't explained the linear part. I'm only talking about... I explained the transformation aspect, but the linear aspect will come probably in the next video. So T is a map. Oh, by the way, we use the word map here. A map is just another word for a function, really. Anyway, so here's a function. It goes from R2 to R3, meaning it takes the vector x comma y in R2, and it sends it to the vector x comma y comma x plus y. So t of 1 comma 2 would be 1, 2, 3, because 1 plus 2 equals 3. What would t of 7 comma negative 2 equal, and what would be the preimage of 8 comma 9 comma 17? Pause the video and figure it out. So I'm sure you figured out that 7 comma negative 2 comma 5 is the image of 7 comma negative 2 under t, and 8 comma 9 is the preimage of 8 comma 9 comma 17 under t.